question using the SMIDI chart. Find the impedance ZN. So they want the input impedance, and it's a 50 ohm coaxial cable. This means that Z0 is 50. And it is terminated with a load impedance of 25 plus 25J, and the length of the coaxial cable is 3/8 lambda. So you could just memorize the direction of where to go, but this is what I like to do. I like to draw the circuit. So this is the load, ZL, and that's 25 plus 25J, and then you have the distance from the generator. So this is 3/8 lambda. That's this distance. And well, do you know what input impedance is?
The impedance of the generator?
Yeah, input impedance is the impedance of the generator. And we have the input impedance of the load, and they want us to find the input impedance. So how would we do that?
It would be the impedance.
Would we go from the load or to the load?
The reference is always the load. So you go to the load.
No. If you're going to the load, think about what it means.
You're going towards the generator.
To load. Yeah, you're going towards the generator.
So you're going towards the load. So from the generator to
you're coming from the load. Okay, wait, say it again?
You're coming from the generator towards the load.
No. Okay, so we're given the load, right? That's 25 plus 25J ohms. And we have this. And from this, okay, we'll plot this point right now. Okay? So ZL 25 plus 25J. So the way it works, if you look at the Smith chart, it says R divided by Z0 and JX divided by Z0. So that's the scale for the Smith chart. So we got to divide the load by 50, which is our characteristic impedance. So ZL divided by Z0 is equal to 25 plus 25J divided by 50. And what is that?
0.2.
Yeah, 1/2, not 0.2, 1/2 plus 1/2J, which is 0.5. So let's plot that, and then you'll understand why it's from the loader to the generator, okay? So you have 0.5 plus 0.5J. So this is our real axis. It literally says right here, the resistance component is the real, right? Which is this. It's labeled. And the complex component, or the inductive component, or the reactance component thing, is here, the JX. And it's over Z0 as well. So everything is over Z0. That's the scale. So 0.5. Can you show me where 0.5 and 0.5 is?
Yeah. Along here, along here, so right here.
Yeah, exactly. So it's right here. So now the next step, in order to plot the point and figure out where it is,
You just go along.
just draw a line. Yeah, I'm gonna make it a better line though, because we want it to be like accurate. Damn. Okay. That should be good enough.
And now you.
Now I'm gonna make it better. Okay. And now what we're gonna do is we're gonna draw this thing called a Viswar circle. Or we gotta draw a perfect circle using this radius. and you copy it. What I'm gonna do is cheat. I'm gonna draw the radius again and just
Oh,
connect it to draw a perfect circle. But if you're doing it on paper, you can't do it like this, obviously.
use a compass.
Yeah. So now we're gonna connect it. It looks curved. Nice. Is this straight? Yeah, it's straight. So now we connect it. Try to draw a perfect circle. So, and we want the circle to like be in the middle of the line. Is that good?
Yeah, looks good.
Okay. That's good enough. And now we could also cheat again. Or not cheat, like just copy and extend this. And this will give us where lambda is. So it tells you the distance. This will give you the distance of the load. You get what I'm saying? So
Distance of the load from the generator.
yeah, so the reason why, okay, we're here right now. We have this. We have this point plotted, right?
Yeah.
And if we're over here and we have it plotted, would we go from the load or to the load?
From the load.
Exactly. We're coming from the load. So we're going this way. Where are we coming from?
From the load.
From the load, exactly. So if it was to the load, you'd be here. We're going to the load. This is just it's kind of a common sense thing. I was confused about it as well. I'm like, oh, what does this from the load to the load thing mean? But if you have the ZL, you'd be over here, and you're basically coming from the load. But if you have the input impedance and you want to find ZL, you have to go to the load from Zn. So that's how it works. Okay, now that we know that, we're going from the load. We're coming from the load. And that means we're going towards the generator, right? Since we're coming from the load, we're literally going towards the generator. And on the Smith chart, you could see right here that the wavelength towards the generator is clockwise. It's this way. Since we're coming from the load, and that means we're going towards the generator, and this is wavelength towards the load, but we don't want that. We're going towards the generator, so we're going this way. And how much are we going by? We're going by 3/8 lambda. So we had, what is the point that we have right now? Is, you tell me.
0. Let me see. Are we looking at top or bottom? Towards the generator. So we're going 0.8. So 0.088.
Exactly. That's like around 88.
Yeah.
So 0.088 lambda. So 2468. Yeah. And now that we have the position of the load, we add it by 3/8 lambda.
3/8.
Like 0.375 lambda is 3/8 lambda, which is equal to, how much is that? That's around 0.463 lambda. So now we're gonna have to plot this clockwise because we're coming from the load or towards the generator. So 0.463 lambda, and it says right here towards the generator, so we're gonna move all the way and find 0.463 lambda, And that's all the way here, 463. And a way you could find it really fast is over here is 0.25 lambda, and over here is 0.5 lambda, and the whole circle is 0.5 lambda. Also, so if you get anything above 0.5 lambda, all you have to do is subtract it by 0.5 lambda. Okay, so this is 0.463,
So it's between
1, so 2, 4, and the middle is right here. And now we're going to draw a line from this dash all the way from the middle, like this. And now the way we look at the new point for the impedance at the generator is we look at our Viswar circle and look at where they connect, which is right here. Now tell me what point this is in this Smith chart.
0.41, and then this point is 0.2. So it's going to be 0.41 plus 0.2.
0.1 plus 0. Is that 2? Where's the 2?
No, minus 0.2.
Yeah, minus 0.2 J.
Yeah.
And yeah, the top numbers will be positive and the bottom numbers will be negative. And it literally says on the Smith chart as well, I'm pretty sure.
Yeah, right here.
Yeah, it says minus JB. Okay. So that's that. And yeah, that was the question. So Zn is equal to 0.41 minus 0.2J. You could also prove it using the formula. Zn is equal to Z naught times ZL. I'm pretty sure, is the formula minus or plus? I think it's plus Z naught tan plus Z naught J tan beta L, and you have Z naught plus ZLJ, and then times tan beta L, and you should get the same answer. So just check. So this is what you get. You get 20 minus 10J, and also I forgot this is Zn over Z naught. We got to multiply it by 50, so we'll get around like 20 minus 10J as well, approximately. So that's it using the formula. And beta is equal to 2 pi over lambda, and L is just your length over here, which is 3 over 8 lambda. So you multiply it by 3 lambda over 8, and you'll get like 3 pi over 4. Yeah, so that's pretty much it.
I want to say like,
And do it in
20
radians.
kilometers or